I'm CK. A little while ago I built this little LED tester and tool from Velleman and I liked it a lot. Very handy tool. I will put a link to that video in the description below. I'm going to forget to do that, so ignore what I just said. So I decided to get their component tester. It's a kit that will test a variety of components for you, and we'll put it together and see how it works. And I hope you enjoy the video. Here's the box. Component tester. Practical gadget. It's got a little circuit board design here, soldering kit, and it's a level 3, so not the easiest thing. Receive all useful information about resistors, diodes, and other components. Auto shutdown, pin layout, 2-second test speed, 9-volt battery, and it's a soldering kit. And we can see it's got a couple of boards, battery holder, display, chip, probably a microprocessor, microcontroller, some general components, and some test probes. Open the box up. Normally Velleman includes a piece of paper as a build guide, but I don't see that in here yet. No, they don't. I guess I'm going to have to go here. Looks like a QR code. Let's look at the main board. Wow, this is bigger than I thought it was going to be. Looks like a voltage regulator. I don't know what that is. Oh, I see what that is. I think these are the test pads, but I'm not certain. And then there's a button here, hold the button for menu. There's where the one IC goes, there's the other one. I don't know what that one's going to be. That's the microcontroller. Resistors, none of the values are listed on the board, so we are going to have to get the build guide. Standard Velleman type board, copper plated contacts, but they are all through-hole plated. Battery. Online manual, so that's the little piece of paper they're having now. And here is where the display will go, which is in here. Get a X-Acto knife blade. Why are you stuck? Don't be stuck. What are you doing? Okay, that X-Acto knife blade is not participating. Doesn't want to come out of the little holder. So we use this X-Acto knife blade. The little component lead on it, as always. Pretty big display. It's 2¼ inches, or about 58 millimeters wide, which is pretty good size. Probably have lots of good information on it. That's nice. And in here, got my parts tray to put stuff in. Take a quick look. Wire. Rubber feet for the bottom. Some test leads, connectors, pin headers, which will probably be for the... No, it won't be for that. I don't know what that's going to be for. 2 sockets, 2 controllers, an Atmel, that's the AT-Mega microcontroller, and this is a Texas Instrument CD4050BE. I've seen that before. I forget what it is. I can't remember part numbers very well. Not one of my specialties. Some spacers. Bunch of resistors with capacitors stuck in there alongside of them. So we've got, as typical for Velleman kits, these aren't all the same value. They're basically the resistors, the diodes, and these should be 104s. These are 101 little caps. Pretty much put in the order of how you want to put them on the board, which is very convenient. A couple of transistors, some electrolytic caps, and some other scattered caps lying around in there. Let's see what this is. Is this a voltage regulator or another transistor? This is a 78LO5, that's a voltage regulator. This one is, gosh, I can barely read the, no, it just goes this way. I don't know what this is. I have to look that up. Big old push button. Angle connector. And that's pretty much it. I am interested in how, oh, I see. Okay. This has got a series of pins on it, very small pins. And that will go in those holes like so. So that looks pretty straightforward. Not too much to put together. So I'll get the soldering iron heated up and we'll begin the assembly. The CD 4050 is a hex buffer and converter and CMOS to TTL, so on. Now the online manual is very, very photo heavy, which is great. And that's the assembly manual. This actually has a separate user's manual, which is different than many Velleman Whadda kits. They often don't have any manual, but I think this one has enough capabilities and options that they wanted to make a full user's manual. So first thing we're going to do is we're going to start putting the LCD PCB together. Oh, by the way, I said this on my last Eurorec build, but I know everybody doesn't watch those, just like everybody doesn't watch these general purpose ones. I got a new lens for my overhead Nikon, and it's got a lot more range. I was feeling cramped, so I wanted to get one with a bit more range. So I'm still playing with where I want to set the focal length for these builds. Please let me know if you have a preference. Closer in, farther out, whatever. Just let me know. So we'll start by, oh, we're looking at various pieces main, but we're looking at the parts right now. So we're going to start with 33 ohm, which should be orange, orange, and black. Yeah, there it is. So we start at the top. As I mentioned, they like to go in order, which is just dandy with me. Put that in here. And like we always like to see, you don't have to bend the leads right up against the body. You can leave a millimeter or two on either end. Now let's see how the solder flows on here. Why is my cable all messed up? Solder flows in there just fine. I'm not going to clip that off right yet. Then we're going to do the female header goes on this one. Goes on the back side, of course. And we'll drop it. And we'll put it over here and set it down on the solder pad. And connect one, solder one pin. Now take a look, make sure it's flat to the board and perpendicular, and it is. So I'll do the rest of those pins. Now we're going to do the LCD display itself. Now these pins are very small, So the first thing I'm going to do is I'm going to use my regular 0.031 inch solder to do these support lugs. And now I'm going to get some really thin solder. For really thin, I use this 0.025 diameter solder from MG Chemical. It's got flux in it. It's full-featured solder, just very thin. And I'll go down this line of pins. This is a place where you may want to think about using some external flux to make sure you don't bridge contacts. And I might, depends on how these first ones go. Yeah, I might, because they are bridging. You can see that I've already got it between two pins, so I'll just suck that little bit extra off. And then I'll get my Chip Quick Flux. And run a line of flux all the way along here, so it's between all the pins, and it keeps the solder from bleeding across. I usually do this when I'm working on surface mount, but the pitch on these connector pins is almost as narrow as some surface mount ICs, so it's appropriate to use flux with that. Not a lot. I probably put too much on there, but I can wash it off with isopropyl alcohol when I need to. Now I'll go back, and my light is shining in my eyes. There we go. See, now I can just kind of run all the way along here, and the flux is keeping the solder from bridging between two contacts. I'm almost just, even though these are not right. I'll suck that free again in a second. Quick and dirty. Get the extra solder off my soldering tip, take a look and see what's bridged. Actually, the only one that got bridged is this one. Just heat it up a little bit, and the flux goes in there and separates the connections again. And now this one is still bridged. There, broke that free. See the way the solder just, I'll zoom in super tight. See, the solder just bridged all that stuff. I mean, kept it from bridging, and everything's all soldered very well. So that's a fun thing to do with flux. Excuse me. Now we're going to do a whole bunch of capacitors. And these are all 105s. They are all 105s. 1 microfarad. How many of them do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. So let's dig out 10 105s. Now, the astute amongst you might have said, "Ah, you idiot, you put the pin header on the wrong side." And I did. I realized that as I was putting that together, so I'm going to take it back off and move it. Now we can put it back on the correct side. And that, I believe, is it for that board. It is. Yeah, I think I threw myself because typically, and again I'm making a lame excuse, but it does, because I just simply missed it, but it does make a little bit of sense to me. The silkscreen has the outline of the connector on this side, and typically that's the side you put the component, and the non-marked side is where you do the soldering. But in this case, that's not true. Let me make sure I didn't misalign anything here. Should be able to drive that in there. Yep, that goes in there just fine. So we'll set that board aside. Now we've got the main PCB. And we're going to go in order, and I'm going to just verify, because they have a list here from R1 to R16. I want to just verify that we've got the right components. I mean, the resistors are in the right order. So yeah, 33K, 3.3, two 3.3s. Yeah, two 3.3s. 2.2, where's it? There it is. 4.7, 4.7. And a number of, 680K resistor. Don't see those a lot. Yeah, these are all in the order I expect them to be. So we're going to put the rest of all the resistors on the board. And not much to talk about there. So I'll put the camera in fast playback, and no commentary. Enjoy resistor time. And that is the end of resistor time for today. All of them are on. Now we'll put the diode on. Nice bold white stripe on the printing on the circuit board, so you know where the white stripe on the diode goes. Now, one thing I didn't do on camera, I did it off camera and I forgot. When I make a repair, like I have to switch something around because I put it in backwards like I did because I'm silly, I do like to go back and check using my meter in continuity mode and just check to make sure with the other pin header in there, make sure all the connections I redid are still good. So that's all good. So we don't have to worry about a future problem. Something unknown happening when we're trying to get it to work and we're saying, why isn't it working, why isn't it working? So let's see, we put all those caps on, and then we're going to put the other caps on. Now we've got C7 and C8, which are the electrolytics, and they are 1 nanofarad each, right? 1 nanofarad 50 volt, yep. And clearly marked plus plus for the long lead, and you'll notice the outline on the board says lay them down. So we'll lay them down because the thing on the top would be interfered with if we didn't put them laying down flat. You don't have to be perfectly within the outline. Now I'll solder these up. What next? Probably sockets. Oh, wait. We're going to put the tack switch on now. I wonder why it's got little arrows. Do not solder the 2 rings that are pointed out. And so we're not soldering these 2 rings. which kind of makes sense. Even though I wonder why the rings are there. Maybe they had a different part at one point that had support lugs? I don't know. But they don't know now. So you don't solder them. I mean, you could. Wouldn't do any. Oh, I see. They're just index pins for the switch so it doesn't rotate. I'm not going to solder that right now because it stays in there just fine. Now we've got 3 transistors, a couple of one BC557, which is probably this singleton here. No, that's, oh no, that's a 557. 557B, in fact. It goes in T1. And T1 is somewhere, there it is. And of course you got to have the flat spot, going to the flat spot on the printing on the board. I'm going to continue to say printing. I used to say silk screening all the time, but I don't think they silk screen this anymore. I think they print it. And these are the 547s, that's T3 and T4. I'm not going to trim the leads on those quite yet, but now we're going to put the 2 sockets on the board. And let me get another longer piece of 0.31 solder. Now this is the smaller IC1. Put it through there, hold it with my pinky finger behind on the back, on the front, and solder one leg on the back. Let it cool. Take a look. Yep, it's all flat. Do the same thing with the other. I'm of course making sure the notch on the socket is lined up with the printing on the board. That's all the sockets. Now we're going to put the female connector on the board. 2 voltage regulators and a reference diode. Let's see what else we have to put on now. Yeah, we've done all that. We could do the pin header now, but we're not going to do the pin header. We're going to well, we may as well do the pin header. Never mind, changed my mind. We're going to put the battery holder on, but I'm going to pause the cameras for a minute. I got to do something else. We're going to trim this down. They say 2.5 centimeters down. See what that looks like. About there. Match it to that one. About there. Take my Nipex strippers, strip a little bit off, not a lot. Now we're going to take the 3, what they describe as Parker screws, and they actually show that these being deeper than, longer than they are. So we're going to go through here. And now we're putting the ICs in, because we're getting near the end, folks. Getting close to nothing being left in the bin. Bend the legs in a little bit against the side of my workbench. Now we've got a notch on the chip, and it'll match up with the notch on the printing on the board and the socket. That's good. Now we're going to make the sandwich as they describe it. Okay, we're going to mate this. Again, I'm double checking all these pins to make sure they're all good. And they do seem to be all good. So now I'm going to put that on there like that. Now again, because I'm the paranoid kind of guy I am, and that's not the snuggest connection, we're gonna test this again. So now we've got the LED panel on, so we're going to take one of these long screws, put one of these spacers on, push the screw further. I'm going to take another spacer. Would have been nice if they had made just one spacer so I didn't have to stack them like that, because that's a little bit of a pain. And if you notice, there's only a couple of threads showing through, so I'm not going to get a huge amount of purchase on these nuts. In fact, I'm not getting any purchase on these nuts. This is not well done here, Velleman folks. Oops, yeah, it's not, there's not enough threads showing through. And that's of course, that's a flathead. Okay, it's not going anywhere. I'll do the same thing with the other corners. We've got 3 wires, 3 test hooks. We've got, put this aside for a second, we've got a red, an orange, and a brown wire, and a red, a yellow, and a black hook, which, as you can imagine, doesn't make a whole lot of sense, does it? Why don't you give me a connector that's got black, red, and yellow wire on it, guys? So we're going to slide the red over the red, like so. And we're going to put kind of through here on this little copper plate. So we're going to put the black wire, and we don't want it to go anywhere while we're doing this. So I'm going to grab my pair of locking tweezers and lock the wire in place. And you want to add, the guide is very clear to tell you do this quickly, because you could be heating up the plastic and it'll melt. So that's the one. And there we go. Those are all there. Now we'll slide this up. Well, let me do one of the ones that's already cooled down a little bit. And there's that. See what it says. Now we plug this into here. Actually, we plug the side that's got the connector on it into here, like so. And that's it. We're set up, except for putting a battery in it and getting some components to test. So let me see what this is. Oops, why is it? First thing that it says is probes 1 and 3, and it doesn't actually number these, which is unfortunate. I'm going to call black ground number 3 and whatever, but first I got to get some components of back in a flash. Now it's time to turn the thing on, and I've got some components to test against it. And the first thing we're going to do is calibrate the tester. And the manual says we got to connect all the leads. So all the leads are connected, and I've got my fluke right here next to it just to see what that says. Now I've got my rechargeable shop 9-volt battery. I'll plug it in here. Try to plug it in here. Do I got it? Yeah, I do. And we'll push this button and it turns on. Self-test mode. Testing. Oh, 0 ohm. That's good. So that's what it should be. And now it's supposed to tell me something. And it should say isolate probe here. Come on, little buddy. Say isolate probe. That's what step 3 is. Maybe if I put the button. Self-test mode again. Didn't seem to do what it was saying. Do it again. Put the yellow on the black. On the red on the black. And it's still getting a very... Still getting 4/10, 6/10 of an ohm. Now we get to isolate probes, okay? God, this is not... Okay. To isolate probes. Then the next one should be the capacitance calibration. I also actually was wondering, how can you do... I mean, you must have to... Okay, now we're going to put the capacitor in here for the final bit of self-testing. I mean, I know this is a good 104. Okay, fine. Whatever you want, little guy. Okay, I'm going to go down to switch off here. Okay, that's switched off. Now I'll turn it back on and we've got that. Okay, that's 96.17 microfarad. I'm fine with that. ESR of 1.9. That's great. Now I'm going to try some other things. I'm going to be... See, we've got this little pad here. I believe that's also another test spot. So what I'm going to do is clear out of that. Now I'm going to put the transistor on there. Oh, it's shown it as a diode. Oh, because I'm not touching all the leads. Well, I'm still not touching all the leads. I'm going to have to do this slightly different way. I'll capture one leg with the red, this leg with the black, and then this one. Now we're testing. Ah, there we go. It's a good transistor test. So that works just fine. I'll disconnect everything now. The only problem I'm really having is on the interface side of this thing. Now I'm going to put a resistor on here. It should be a 220K. And you notice I'm not turning on the fluke because this is working just fine. Yep. Just said not calibrated. I don't know why it said that. We just went through the calibration. So this is supposed to be 220K and it's coming in at 221, which is dandy. What else do I have in here? Oh, let's try an electrolytic. And I'll put that in the probes with the red on the long lead and the black on the short lead. And this should be, this is a, what the heck is this? It's a 4.7 microfarad. Keep saying not calibrated. Now, I've got two things to say about that. 4,800 nanofarad, so that's very close to 4.7. I'm fine with that. Now, one thing about the calibration is, because I didn't solder any RAM on here, even DRAM, I think the Atmel chip has some dynamic RAM, or static RAM, I mean, but I don't know how to verify whether they're using that or not. One other thing, if we saw, yes, we know you're not calibrated. I went through the calibration. Do you have to calibrate it every time you start up? Gosh. One thing I noticed in here is we've got frequency something here. Let me look in the user's manual real quick. Okay, so we'll go to F generator and do that. That's 100 megahertz. I'm going to go over to my DC hertz on the fluke measurement of DC hertz, that is, and hook these things together. And this is supposed to be more than 1,000 megahertz. We're not doing that. Why is it not doing anything? It's showing 1.9 hertz right now. Okay, now I've dropped it to 50 hertz. And the fluke is showing, as you can see, it's showing like 97 hertz. I'm sorry, that's greater than 50 hertz. This button is problematic. Yep. Now we dropped out and frequency generation is still going on for some reason. So that's 10 hertz. So it's looking like the frequency that generates is actually doubled. This button is not real good. Yeah, the frequency reported on the fluke is double what is showing on here. I could probably drag a scope over here and get a better view, but I'm not going to do that. Let's see, we've got pulse width modulation. Let's see if we're getting anything on that. Oh. Get that again. Greater than 10-bit PWM. No, it looks fine. That's capacitance plus ESR. We already saw that. That's induction. Regular capacitance. Rotary encoder. I don't have a rotary encoder handy. Let's see what we get as a result on here. Let me get a cap, another cap. I'll take this 100 nano one again and see what we get there. Long press that. 0%. Okay, fine. I'm happy that you're at 0%. Set the contrast, switch off, transistor, we did that. So we've done pretty much everything here. It certainly works. It's a little bit clumsy to use. I'm not sure that, except for the frequency generator, I'm not sure it gives you much more than what a modern digital multimeter gives you. And it's, again, a little clunky and you have to keep turning it on, and the calibration didn't quite work. But if you don't have a multifunction DVM, then you can put this together. It's inexpensive, and give it a try, and it'll give you certainly some good stuff. So that's it. It's not quite as handy as the LED buddy, which I'll leave a link to in the description if I remember, which I probably won't. But it's a good little unit, and again, relatively easy to put together except for the short screws on these spacer items. So that's it, and I hope you enjoyed the video.